I don't know if I can maintain that enthusiasm. That's exciting. Although I brought the right shirt, I think. I was in Miami a few months ago, and I was like, I have to have that shirt. I don't know if it works in India, but I like it. So just so you're aware, I am not as prepared as I would like or plan to be for this talk. That said, I have a lot of information we could talk about, and I have slides. I am going to be doing demos. My challenge is, I don't know if it's as organized as I would like it, so hopefully we can be okay with that. But that's kind of like, I'm going to take that as an opportunity to spin it positively, right? You guys, it's like the read your own storybook, right? You're like, you guys get to decide what order we want to do stuff in. How cool is that? But I also want to make sure we get some core concepts out, because I can ramble on a little bit. I don't know if you've noticed that about me, but I can. So we're going to talk about Spark. There's an interesting story about Spark, actually. Does anybody know where Spark started from? Oh, the other thing on my slides, I'm actually going to switch between some some slides that are kind of HTML based and some slides that are up here this based, and at some point I'll need to bring them all together so you have them. But that will happen, and you'll have my email address. It's just Ken Sipe, KENSIPE @gmail. And so if you, for some reason, find we're short on that, you can harass me, right? Spark, where did it start from? Where did this all start? It started at UC Berkeley. And it's got a fascinating story to it that oftentimes is kind of lost, it's missed. But I think it adds value, and I'll be talking later on today about data agility. I'm not sure who in here will be at that, so I'll have some duplicate things that I'll say there as well. But when we get into like where has the data center been, where is it coming from? Like, we could go back all the way to Google in the 2009 timeframe. It also brings us back to kind of the start of containers. Now we had container or containerization prior to that. But Google did something really interesting around 2008, 2009. They submitted the LXCs to the Linux, to the open source community, which is fantastic. But what's missed is like what brought this all together, right? They had something internal which is called the Borg. It was top secret at that time. They didn't talk about it outside of going to academia. They would go to academia, that included UC Berkeley, and there's an interesting people there. One of those people is Ben Heinemann. Ben Heinemann is the creator of Apache Mesos, and I work for a Mesosphere, so I see him regularly. But when we built, there's a lot of things to cover. I don't know if I will cover the data center stuff in here in this session, although I have some slides prepared if we go that direction. But when we built this abstraction layer for the data center, you needed something on top of it to orchestrate, to do something. Like we built these really cool libraries to abstract the data center. And the core concept there is, in fact, let me take a step back again because I think it's so important. Google looked at their data center and they said, how can I leverage as much business value as possible out of what I have? I've spent a lot of capital money, right, on this. How can I leverage that to get as much value as possible? That was the question. Now, this brings me to an interesting point that when I talk about in this session and later on my last session tonight on the data agility, kind of some misconceptions that I see commonly in most organizations. Because what you see in most organizations is this. You have your microservice-based architecture teams, or essentially web-based teams, and then you have your data agility teams, or essentially analytic teams. And not only do we have separate teams, but they have separate clusters. They have dedicated machinery that are dedicated just for analytics, which is almost comical. And I know that might sound weird because you're just used to it, but it's almost comical. But I have to take you back and tell you a little bit of a story on Google and hopefully bring that forward. And then I'm going to dive right into some Spark, okay? Well, I didn't expect a crowd. This will teach you. I need a bigger room next. I'm really glad you guys came. Okay, the Borg. When you have a huge data center and your job is web search, You have peaks and valleys like you have for any other business, right? Sometimes it's completely saturated and sometimes you're idle. By the way, does anybody know the number, the general number that we use for how utilized a data center is most commonly around the world? It is almost always less than 20%. I've been personally helping companies with Mesos and DCOS and some things like that, and it is common for me to come across data centers that are at 5%. We're at 5%, right? Now think about it for a second. There are some interesting aspects of that. One is, if you're in the floral industry, you're going to be taking orders for flowers. You have 2 events in the year that like saturate your servers, right? Any guesses? Valentine's Day, Mother's Day, right? You know, for 2 weeks to a month prior to those events, you're busy. You need like 1 machine the rest of the year, and you might not be utilized on that guy, right? So, shame on us, right? On us men. Yeah. So, but you have to make sure that you have a data center that will manage your peak load season and your peak times in your peak seasons with some extra headroom usually, right? And you also have to plan in the future because these are capital expenditures. I need something that's going to last me a couple of years, and I'm going to depreciate that over time, and I don't want this to be an accounting class. So the question becomes is, if I have all these unused cycles, what can I do with them? And that's what Google did. They created something called the Borg. And what they ended up doing is, think about this concept. You have guaranteed services. You have guaranteed reservations, we would call them, in your data center. So you might claim out of an entire data center, I'm guaranteeing 70% of my traffic will be for web search. Fantastic. Now again, that's a reservation. That's what I expect to be guaranteed because that's my business. I can't lose that. But I might have what I would classify as best of service. And this could get into a whole architecture talk at this point, right? But I'm not going to today. The core is we need to categorize these services. And one type of categorization is, you know, if you have some cycles, this thing could use it. Which means that if I am 70% guaranteed reservations, but I'm only utilizing 30, I've got 70% that I could use. Is that true? If I have a system that would know to evoke any running services as soon as I have some peaks in my guaranteed services, because I have to. I have to have something that's monitoring and orchestrating that will just kick out processes and say, you know what? I would love to have finished this, but you're best of service, and I've got to make room for guaranteed services. That's what we're talking about. That's what the Borg is. That's what it was. Now, if you're following, if you're in this industry and you understand it, Google has moved away from the Borg. Well, they actually still heavily use the Borg, but they are moving towards a thing called Omega, which is basically their replacement, and it's proprietary. There's no reason to. There's also this misconception that Kubernetes is like this. Takes all the ideas out of the Borg and out of Omega, and now it's available in Kubernetes, and that's totally wrong. There's not one lick of code that transferred over. Now, there might be some concepts. The concept of a pod has transferred over because that was something they do very commonly, is they have containers that live together for good reason. Okay, so if you've built a system, in fact, there was a great talk 2 or 3 years ago by John Wilkes, who's considered to be the godfather of the cloud, which is a great title. How do you get that? That's awesome. The Godfather. I expect to be woken up with like a horse head or something. But he had a really nice slide, and it had varying lengths of white at the top and different colors that spanned kind of a time chart. And the white was idle time of a core, of a CPU. And it's varying lengths, but it's really short, right? And the other colors were different processes that were running within a given node. And he said, at Google, white is evil. They want to leverage every single cycle for business value. And I'm telling you, this is, again, an opinion of Ken's, right? It is my opinion that this is what put Google so far ahead of their competition. They were able to leverage every dollar for business value. Now, think about it for a second. How did they do that? Now, I want to put together one more thing, and then I'm going to move into the slides, okay? And actually some code, if you don't mind. Around that same time, they came out with the Borg. They're going to utilize every cycle. They have classifications of services. They came out with an interesting paper. And that paper was, we knew that paper to be MapReduce. Interesting. What would you need? What would you need if you had best of services, knowing that that service could be killed at any time, but then reincarnated once cycles were available for it to start back up again? What would you need for that? I would need to be able to batch things. It's a great point. I would need to be able to persist things, checkpoints, such that when I started back up, I could get the checkpoint and go, oh, this is where I left off. Let's start again. I would need all that, right? I would need all that. So these all, in my view of the world, all these things stitched together to create a really neat model, which is a significantly different than what we see in everybody else's data center. Because what they did was to leverage every cycle of their data center for business value. And what I see in most data centers is, here's a cluster dedicated to analytics. And here's a cluster that is 5% utilized, that is dedicated to microservices. And we're doing it wrong. Well, up to you. It feels off to me. Because here's the challenge. I'm about to dive into Spark a little bit more than I have so far. And we're going to talk about how Spark is kind of taking over. It is taking over MapReduce processes and analytics for lots of good reasons. But one of the biggest, most important reasons is it's faster than Hadoop, which has been the dominant MapReduce processing tool in our industry. But why is it faster? It's faster because it rarely checkpoints things, and it runs things in memory, and it does things that if you have a dedicated cluster, you would do. And frankly, the fact that you do a ton of checkpointing in Hadoop is ridiculous, because you don't even have best of services. You have dedicated platforms and dedicated services. So the things are, in my world, seem off. All right, is that too much? No? All right. Ken's not completely crazy. That's good. So we're going to dive into some Spark. And I went through that whole story for a couple of reasons. The follow-on reason is the open source option for the Borg. As I mentioned, Google went into UC Berkeley. Ben Hyman was at UC Berkeley. He saw what was going on. He created Apache Mesos, which is essentially the open source option for the Borg. But there was a problem. And the problem was, Mesos by itself is a really interesting tool, but it doesn't do anything. It doesn't schedule anything. It needs a schedule. It's a two-level scheduler. So it has that first level. It's a nice abstraction, does some really cool things. But it needs something to validate that this thing even works. And the very first scheduler ever created for Mesos is Spark. They were like, well, Google just came out with this MapReduce paper. What if we did one of those? And they created a MapReduce process written in Scala that runs on top of Mesos and was the very first scheduler. Now, Spark has taken on a life of its own, and now it's different. Now you could actually run it in a Hadoop cluster, or you could run it standalone. You probably wouldn't really, but your two common modes you would probably run it into a production environment would be on top of Mesos or on top of Hadoop in some way, or a Hadoop cluster. Is everybody good? All right, so I'm going to start diving into a little bit. And as I said, I've got a couple of things, some code that we'll probably dive into. Ooh, I did not mean to do that. That's a no-no. That's my first test, is never multiple clicks. So we're going to dive through some overview. We'll talk about what the most important part of Spark is, actually, is an RDD. We'll also cover, like, one of the beautiful parts about Spark is once you go down the Spark path, there's a bunch of libraries that are valuable for general analytics. So it's kind of a cool thing. A lot of folks that are moving into Spark use it initially for MapReduce type things, But then they're like, hey, there's this streaming thing. And actually, there's a whole nother group of people like, I have streaming requirements, I need something. There's probably several good options out there, but the two that stand out would probably be Storm and Spark Stream. So those two are probably the most popular. And in fact, there's a whole stack out there that I'm not going to get into in this talk, but we call it, the engineers called it the SMAC stack. It was Spark, Mesos, Akka, Cassandra, and Kafka. That's a common data agility stack that you might look at. Marketing didn't like the SMAC stack for some reason, the name. I don't know, I don't understand it. Who cares? What's in the name? All right, so let's dive into it. First of all, it came out of UC Berkeley. It's been around for a while, 2009. There's been a lot of advancements since then. Interesting thing, of course, since it was the first scheduler on top of Mesos, both of them came out of what was referred to as the AMP lab at UC Berkeley, but they kind of went different directions, right? Ben's actually friends with, can't remember the guy's name, but he's the head of Databricks, and Databricks is essentially the company that's behind Spark. We've been trying to kind of bridge some things from a business standpoint with them, and they're not really interested. So I don't know what will happen there. We're taking on some responsibilities on our own, meaning Mesosphere. They are looking to provide us a cloud-based service, and we're looking to, like, if you know what we're after as a company, it's to enable people to be abstracted from any other cloud provider and still be able to stitch together some really, to decouple people from vendors. That's what our focus is. It has been for some time. This is the layout, essentially, the lay of the land. We have Spark SQL. Oh, I didn't even mention this actually yet. I won't dive into this later on, so I might as well talk about it now. There's a component called Spark SQL, and you're like, well, why would I do this? Well, it turns out that a lot of organizations that are in this space, they need a data store of some sort, and they're oftentimes in a high-scale environment. And the most obvious, I shouldn't say it that way, the most common choice that we see is Cassandra. Regardless of why. Like, I don't know if I want to get into why. Now, I think one of the huge drivers is Netflix uses it, and they've come out with, you can't see a Cassandra presentation without seeing the Netflix chart that shows linear scalability, right? So there's been some pretty good evidence that it scales linearly, whatever that means to people. Use case driven, of course. You could probably screw it up if you wanted to. But there's a problem. If you're not familiar with Cassandra, it's a key value pair store. It's a NoSQL database. Always a big fan of the term NoSQL. I don't know how many things we're going to have in our industry that are going to be the absence of something, the not SQL, right? It's like saying a car and a truck and an airplane is like no motorcycle, right? It doesn't make sense to me. But it doesn't have any joins. That's the point. It doesn't have a way of doing some joins. It's just the nature of the beast. But commonly you may want to do some joins with this assumption. You're not, and this is where I have to be a little bit careful, right? You're not looking to have answers as a response to a human click on a website and provide an answer back. That would probably not be the use case for this. But when you're doing analytics, you're trying to chew through some data and trying to understand something, and then probably, most likely, writing additional data as a result of something, and then showing that result to a human. So it's very common in this model to, it's kind of like, it's very anti-relational data store. Because in the relational data store world, you're like, how can I not ever have any duplicate data? Ever, right? And we actually are the antithesis of that. We commonly are redundant. We'll write data as a result of something, as opposed to, we'll execute on write, or before write, as opposed to execute on read. It's a very common model we see. So when would I want to join things? Well, when I'm doing analytics and I don't really care about the processing time for the most part, and I will eventually write an answer down, and that answer is the thing that is provided to a human or something that needs it in a quick fashion, whatever that is. All right. So there's a great place for Spark SQL. It is almost always used as that joining mechanism for Cassandra instances. We see it all the time. That's also why when you look at DataStax, which is the company behind Cassandra, they have a very close marriage with Spark, because almost all of their clients use Spark SQL to do some kind of join in some fashion. All right? They're very, very tightly associated. I mentioned, no, it does not. It does not. I have plenty of clients that I've worked with that have zero Cassandra instances installed. You're left with probably storing something in some kind of persistent store of some sort, right? There are a lot of teams that I've worked with that will pull data out of HDFS, so or like an S3 or like a blob of some sort. So you have a data store, a file system or Gluster. Yeah, there's lots of options. But you're pulling something out of a file system, it's kind of an unstructured data store, chewing on it from Spark and either providing an answer, storing it in some other relational data store, or stuffing that into Cassandra. And that's actually the hard part. If you're looking at building a whole system, which I'll get in later today, one of the challenges is when you're streaming in data, what do you do with it initially? A lot of organizations go straight to Cassandra, read from Cassandra, do some analytics, and then back into a Cassandra. Some will go into a Kafka, and then the Kafka becomes somewhat of their data store for multiple streams going out to different stores. There's a number of options there, yeah. But to your exact question, Cassandra is not needed for Spark at all. In fact, one of the demos we'll do in here will just be Spark on its own. It's kind of a trivial example, but it shows that we could just use Spark, you know. It's a great question. Is there another one? Am I going too fast? You got me all excited, see? You're not even with me anymore. Got me excited, left me hanging. Okay, so they're awesome. We can follow on the stack, like there's this core piece, right? And I'm going to spend a little bit of time here making sure we understand the core. There are some core things that you would do. We have to explain RDDs, because that is the data format that is leveraged by Spark. Once you are in an RDD format, there's lots of cool things we can do. You would commonly do maybe some transformation-like things, and you're probably familiar with this, frankly. There's certain, especially with lambdas being added into Java, many Java developers are quite familiar with a functional style programming that kind of comes out of this space. So mapping something, and mapping means taking something and transforming it to something else. Folding something, so you're folding in on something, right? We'll go through a few of these, so I don't want to do too much hand waving, but we'll get to a point. There's events, there's transformations, things like that are kind of in this core. There's two core things you want to know when dealing with the core of Spark. One is RDDs, as we talked about. The other is the context. There's a context that's managed. Once you know those two things, the rest of everything else you just have to look up as you need it kind of stuff. You know, what are you trying to accomplish? Then we have on top of the core, we talked about these other two things, we also have ML, which is our machine learning. So some really cool things there. And I know less actually about the graph processing. It's a library, I know it's there, but I don't have context, so don't ask. Right? I don't have it. Okay, that's the core of it. In fact, where do we want to go? Let me go here. Oh, a couple of things. I am going to show at least two demos, hopefully, if we have time. One of those demos will just be at the shell. If you download this, let me take a step back. If we're going to be coding something in Spark, in my opinion, well, skip my opinion for right now. If you're going to be coding in Spark, you're going to have three language choices you're going to go with. Scala is probably this is my opinion now, is probably your best choice. You're going to see most examples in Scala. We heard last night from Greg that Scala may not be the choice if you're, I don't know, you'll have to make your decision whether we want to be polyglot or not, right? Your other choice is Java, and there are increasingly more examples with Java, but there's kind of a mismatch when using libraries between Java and Scala. And Scala's actually really good at using Java libraries, but Java is not as great about using Scala libraries, in particular if Scala didn't keep Java in mind, if you will. So there are certain techniques you can use in the Scala world to help alleviate those pain points, and not everybody is either aware or implements them. So in my opinion, it's probably best to know some Scala if you're doing this. Your other option will be Python. The example we're going to show in here is Java and Scala, and I'll make sure that you have those examples available to you. So, but you'll probably be able to find them as well. So two examples we're going to be looking at in here. One is going to be in a Mesos cluster. DCUS is the product that I work on, which is open source, otherwise I wouldn't talk about it. So I don't tend to show commercial stuff. The second is just the Spark shell. And when we're using the Spark shell, it's going to be kind of Scala-based stuff. And that's the other reason why it tends to be that people use learning Spark, learn Scala, is that when you're in the Spark shell, it's a Scala shell. So that's what you're learning from. It's like a REPL. And when you are learning how to work with Scala from that REPL, it's just easy to take those examples and move them into code. And at that point, your code is Scala. So just be aware of those things. All right, so where do we start? All right, I'm going to continue and see where we get. I want to add to it. So general, as I mentioned, can I get rid of some of this? Not sure why this is acting that way. Okay, there were some project goals to it. I don't know how important that is. We talked about the layout of this thing. One of the key elements is that it's really fast. I actually have some data here to represent what that means. The core part of it is that it's using in-memory data querying. When you're using the shell, you're doing standalone, you're working on your machine, your local machine, which is awesome. I can do it in a disconnected mode, which is great. When you're using it in the real world, though, you're using it in a cluster. And so I'm spinning off these jobs that are managed on a number of different nodes, which can add a lot of value, right? So then you're batching, essentially. These are batched out. The RDDs can then be transferred across these different nodes and processes and then brought together and joined and such. There's a variety of ways that is managed. Okay, so in fact, that's perfect. This is what I wanted to get to. Your typical environment when you're in a production world will look more like this. I have some kind of driver, which is the way you're setting up your Spark context. It's essentially executing through the script, driving a cluster, which then has workers out in that cluster doing the actual work. So it's fairly simple. Of course, it's simple in a diagram, right? The core of making that cluster work is actually somewhat challenging in that it has to be fault tolerant, among other things, right? The speed of it, it's said to be 100 times faster than MapReduce. I explained why, though, right? Like, don't let this fool you. It's still Java code compared to Java code. It's slower because of how things were designed. And we're also seeing some improvements, frankly, in the yarn space. I don't know how many people are familiar with the MapReduce analytical space. Hadoop 1 came out and kind of dominates the world. There's a couple of challenges that are worth pointing out in that space. The first is that when you want to move from Hadoop 1x to Hadoop 1y, you basically have to decommission a whole cluster, and then basically the versions aren't compatible. Let's just put it that way. And there's a huge process, it's a costly process of moving from one to the other, because you're usually looking to verify that pre-existing analytics will work in the new Y version, like they did in the X version, to confirm that you're ready to move forward, which is somewhat challenging. Where was I going with that? I don't remember. So Spark. There is a special test as far as benchmarking goes, which is called the gray sort. There's actually a couple of them. I can point you to one of my favorites, actually. It's the TerraSort. So the TerraSort, which was probably the sorting mechanism that won Spark kind of notoriety, what it would do is it would create a terabyte of data, random data. That's its first job. It would stick it into an HDFS folder. It would then read that and order it and sort it, essentially. And then it would store that. And then there's a third function that is then validating that. Validates that everything is stored in exactly that format. And it's way, way fast on Spark. And that is kind of the, in my opinion, that's the benchmark that kind of sets the standard. I don't know if you're familiar with Jim Gray. It's an interesting story to him. He got lost out at sea and perished that way. But the sort mechanism is another one of those standards. You can see the different comparisons of MapReduce versus Spark. Oh, I know where I was going with that story. Hadoop 1 owns the world to a certain extent. Because there is so much work going into moving to Hadoop 2, and there's another option which seems to be faster, most organizations who are already on Hadoop 1 are seriously considering Spark as the alternative as opposed to Hadoop 2. So just so you're aware. Not, sometimes that doesn't mean a complete replacement. They're still going to use Yarn with Spark on it. But they have more options than they had before. All right, so I'm not going to read the data, but you'll have access to it. That is kind of the core of it. It's highly flexible, as I mentioned, the 3 different languages that you can use. Spark Shell. You know what, instead of doing that, which one am I on? There we go. So we have the Spark Shell. It'll take a second to start up. So I'm going to start that demo now. It'll take a few seconds that we're not going to just sit there and watch it. The other thing that I'm going to do is go over here. I have a couple clusters that I created a couple hours ago. I have one pre-made in case bad things happen. It's sort of like going to those cooking shows where I just pull something out of the oven and go, hey. But we'll try to do some of the recipe first as well. So this cluster here doesn't have anything on it whatsoever. I will jump out here and say DCOS and spin the cluster up. Oh, that feels bad. 1 second. Huh. Yeah, I'm off the Wi-Fi. I'm on a wired for a reason that is not. That reason apparently doesn't exist. Let me just double check something real quick. And if we don't have that demo, I don't think it's the end of the world. I'll at least have the Spark. That's actually why I had to. What's that? Yeah. It's not. I could switch to Wi-Fi if we think that's going to. I don't know how much troubleshooting I want to do. I got a lot to cover, so whoops. It's quite a bit of stuff. Yeah, it says it's on. All right, one last check. We'll go here. Nope. It's not. Oh. You guys commonly get like brownouts and stuff like that? Oh, I don't know. All right, skip that for a second. I don't know how important it is. I'll see what I can do. But here we have our Spark shell. So now we're working in Spark. I also have somewhat of a cheat sheet with me. What I didn't show you as well is I have an input file that looks like this. The input file just has some text in it. We're going to play with that text. It's not a big deal. Also, since I have that Spark shell up, now that's just running locally, right? Since I have the Spark shell up, I can move over here and go to localhost. Oh, am I a liar again? What is going on? I can't get to localhost? Or you it's my machine. Yeah. Yeah, maybe there is a proxy that's in my way. Okay, well, skip that. Imagine a really beautiful UI. It's actually not beautiful. One of the downsides, by the way, do you remember like Bugzilla? Has everybody been around long enough? Yeah. So Bugzilla like worked. Yeah, it worked, but it was pretty ugly. It worked, right? I don't want to say the Spark UI is Bugzilla, but it's close. I shouldn't be so harsh, but it has a number of tidbits of information that are worth looking at, though. And it really isn't meant for a business person to be looking at. It's probably easiest to say that, right? You never want your business person looking at Bugzilla. That's for you, the developer. Same thing's true for the Spark shell. It's really about debugging things, seeing where things landed. There's some really cool things you can see from that, which you can't see here, but believe me, you can see the jobs that are running. You can see the RDDs that are there. I can see what the storage mechanisms are. I can see that something was stored. I can then unstore things. I can see all that activity. And I can see how a job, like a really big job, has been partitioned out to a number of nodes. And I can see the progress that's being made on those nodes. So all of those things are really useful tidbits of information that you can gain from that UI. Let me see if we can get to... Oh, I'm on. Good. Okay, so at least I got my local host going. And you can see I have nothing in the storage right now, and I don't really have any jobs, but I didn't do anything, right? I just started the Spark shell. The fact that I started the Spark shell gives me access to this UI. Localhost at 4040, right? So let's start doing a few things. Again, I'm going to work a little bit off my cheat sheet, which again, you can have access to. It's not a big deal. But I'm going to say I want to read in that input file. It's already stored on the local system. Notice a couple of things, that it's an RDD was created based on reading that in. It doesn't matter where you're reading stuff in. And eventually we'll look at more of the API that's available to us. But I can pull things right out of Cassandra. I can pull things out of a different data store of some sort. I can pull it right out of the text file, as you see here. And everything, all data that I pull in becomes this RDD format, which I'll get into more detail in a few minutes. But the core of it is that is your fundamental data store, your data structure that you're working with, that you want to be aware of. So yeah, well, a couple of thoughts there, and I don't know if I'll actually answer your either question or point, but almost always when working in analytics, some of you might have gone to one of my sessions yesterday. We were talking about memory and managing things, and I almost always hyper-focus in that around microservices. This is a different use case, and in the analytical space, we almost always have really, really large Java processes, and they leverage almost all of that space. So the heap sizes oftentimes are very, very large. It's up to you as how do you want to process the data coming in. You may parse in the data as opposed to reading the whole thing in. This happens to be an easy demo, right? But in the real world, that's probably not what you're doing. You're probably reading in segments of data.
So can you explain what exactly you're trying to read?
Yeah. You know what? Let me do that. Let me do that first. Which is, I think, very shortly. I'm going to drive towards your answer, and then jump back into the code, the demo code. So the first point that we're working with. Notice what I did here. I just read in a file, but I did that through the SC. Do you see that? I said SC. There's a couple of implicit variables that are available within your Spark environment, at least from the shell standpoint. And that is the SC, which stands for Spark context. It's the Spark context that we're doing things with. This next slide here then indicates the API that's available from the Spark context. What I love about Spark in general is that there's a lot here. When you look at doing the analytics, doing streaming, doing again, the analytics and streaming, they're up here. There's a lot of things you can do. But the core stuff is super simple, in my opinion. this API here is just working with the context. And then you can see here I could add some files, add some jars. The most common way, you're not seeing it here because I have a simple demo, but the most common way that you're going to launch a Spark job is you're going to have some Spark code. You're going to compile it into a jar. You're then going to push that jar to Spark and say, hey, run this jar. Here's the class I want you to run in that jar. Oftentimes, you will stuff that jar into like an HDFS environment. That's probably the most common way, but it doesn't matter. I need a way of being able to fetch or download that jar so that Spark can gain access to it. That's the only requirement, right? So I need it available somehow on the system. In a distributed world, it's very common to use HDFS or something, whatever you have for your distributed file system. You can see I added a jar. I could add in some Hadoop-like things. I can parallelize things. And we're going to see a couple of examples. So I did something real quick, which was read in a text file. Here you can see, I need to blow that up so you guys can actually see it. But here I'm going from 0 to 10,000 and giving me an array of numbers. Notice a couple of things. First of all, it knows that if you ask for the printing out of some large structure, it knows that humans are idiots, right? It knows that. So it's just not going to do all of that. It gets to a certain point and says, yeah, there's more here, essentially, which is nice. And so there you can see that I actually have an RDD associated with those numbers. And as soon as I parallelize, what I'm asking it to do essentially is I have this array of things, but I want to bring that in and get an RDD out of it. It may be so large that I want to use the whole cluster to gain that. And it's up to Spark as to figure out how it wants to manage that kind of concern. There are some things that you can manage, like how you want to chunk things. There's a little bit of control over things. A lot of it's configuration up front, not necessarily part of the job itself. You've already seen me do this where I'm reading a text file because I just did that. So we read in a file, it's also an RDD. And then to your question, what is this RDD thing? What does it mean? Whoops, there we go. So it's a shared memory format. It's somewhat coarse to grain. The other really core part of an RDD is that it's immutable. It's immutable. All right. So if you have some kind of transformation or you have some accumulator of some sort, you essentially are getting another instance of a thing. Everything in this space is immutable. Yeah. All right. It's obviously serializable as well. It's going to be serialized from process to process. And then there's some transformations we can do on this thing, right? So, so the things that we can do once we have an RDD, I can do a transformation. This would be like map this thing to something. What's a simple example? I don't know. For every word, give me a 1. That's a weird transformation, right? But that's a common thing to see in analytics. Then I want you to fold the ones, because that's a fun thing to do. You might perform some action. And there's associated triggers with that. I'm going to show you some slides with that as well, so hang on. If you're talking about what can I do with the RDD itself, this is a listing right here. If you're going to persist that thing, then you're going to mark it with a cache. That's just a function to say, hey, I'm about to persist this thing. I can checkpoint it, and you can see the list of things. The things that we talked about from a transformation, the things we talked about from lambdas are all going to be on there. Filtering, mapping, folding, counting, collecting. Those are all things that I would expect to do with some kind of data. Yes?
Is this roughly equivalent to the Hadoop block, this RDD?
It's similar, yeah. Yeah.
Since it's lazily evaluated, let's say you do map, it could be like,
Yep.
it's going to create 15 RDDs, or it's going to create 1 as determined.
The very low specifics, I don't know if I'd be prepared to go into, but there are some things that are lazily evaluated, as you pointed out, which gives us the ability to not actually realize the thing if it were to be like excluded through a filter. So you may have a set of data, a large set of data, that is actually never completely realized because your filter eliminated all but 2. So that is a possibility. Yep. Okay, so if we had an RDD, one of the things I could do is say count on it. I don't think that's what I have for my example. What do I have in my example? I have something a little bit more complex, and don't be confused or anything about this. It's not a big deal, but notice I've got some things that if you're used to lambdas in Java, you would expect it. I'm sending in, and again, we're talking really Scala at this point, okay? But I'm going to do a flap map on what the input file was, which is going to give me essentially every line of data that's in that RDD. Every line, so essentially every line in that file. I'm going to split that line based on a space, and then I'm going to map, with the split, I'm going to get a bunch of words, right? And then I'm going to map the word to a 1, and then I'm going to reduce by adding that together. So that's a series of events that are about to happen. I have a line split based on space, so now I have words. A word is going to represent a 1. I'm then going to count or fold the ones through an addition or reduce. Reduce is fold if you're not familiar with the mapping of that word. So let's do that. And there we go. And we're in a Scala shell, so you could just use without the semicolon. I don't know why I added that in there. You can see my Java influence coming into. This is the problem with being polyglot. You often using too many semicolons when you don't need it. Just some helpful hints for you. Some added advice, especially if you're new to this and you're like, I really would like to know more about what's going on. There are some like debug strings. So what I'm showing here is that, by the way, when I'm flashing things is to have it as far up to the top as possible so everybody can read. But all I'm saying is give me an understanding of what's happening here with this counts thing. Counts, if you remember, was equal to that whole like mapping of things and the folding of, or the reducing of things, and it's equal to this value. So you can see a little bit of where it came from. It's got some historical information there. And then it was reduced by a key. That was the last operation that was done on it. I can actually see what's being done, which can be really, like it seems so simple here because this is a demo. But this can be really valuable when you're looking at a distributed data set. And you really want to understand for this RDD, in this process, what has it gone through, right? It's super important, very helpful. As I mentioned before, one of the APIs on the RDD is I could say I want to persist it. This gets it prepared to be persisted. It doesn't actually do the persisting itself. The next step would be you have to decide where you want to persist it to. In this case, I'm just saving it to a simple file or not. What did I? Oh, that already exists. No, it doesn't. Take that. I win. All right, so there's some staging that we're going through. Again, it's not enough data to really process a whole lot, and we wouldn't want to do that when we only have an hour to talk about things, right? But I can go back out to my UI, to the shell. I can start looking at a few things. I can see that I actually did launch a job. This one's super simple, just saving data. I can start diving into that and see that it has a couple of things that it went through in order for that job to function. I can go into the storage mechanism and see that there was an RDD that was shuffled and that it was stored. So that's kind of the details and the amount of data and how much memory was consumed and all this other stuff. What the executors were. Seems too simple here, but notice that over here I have an IP address associated with the executor that actually performed that activity. Again, in the clustered environment, this is really, really helpful debugging information. So, yeah. Oh, I'm sorry, you meant right here. This right here? I'm sorry, this right here, I mean. Oh, how do I control this? Yeah, I don't know if I know the answer to that. You can have some control. It's at that point, it's kind of an implementation detail. And so if you had a different storage that you're reading it from, you have control over, okay, this is not a Hadoop thing, this is going to become another thing. But why the internal implementation details decided to use a Hadoop RDD, I'm not sure. It probably was the simplest thing to do because it already existed, kind of thing. Typically, when I'm reading a file, this is a demo, right? Typically, when I'm reading a file, it's coming from HDFS. If I'm coming from HDFS, I'm coming from a Hadoop space. So it's not terribly a surprise to me that it's that class implementation detail. But oh. Oh, what was this? I'm sorry, yeah. Why did this occur? I'm not sure if I know exactly why that occurred. It may have been necessary in order to map into this flat map, right? So there was a transformation to even make the flat map possible. You know what? Actually, hold on a second. It's coming to me. You remember when we read in the file? I had to read in the file to get lines. And those lines then were transformed into arrays of strings, words, right? So when I read in the file, I read in an RDD of the file. When I then mapped to the lines within the file, that was a transformation we didn't care about, but it had to occur, and it mapped into the map partitions RDD. Does that make sense? I don't know if we want to hyper-focus on that, but I do think I think I do understand how it ended up getting in that space. And it was really about, there's transformations that occur. At one point, I just had a blob of data. At another point, I had lines of data, so the 4 lines. So I had an RDD representing the 4 lines. Then I had each one of the 4 lines representing words. And so there was a transformation that happened at this point for that reason. All right. I think the remaining thing, where I left off was I actually scored big, right, when I saved. I won. So these files were created for me. This is kind of that checkpoint, if you will. Like, hey, this process is about to be killed. Why don't we store off where we're at this point so that if I want to restart, I can. And that's what was created. And it's fairly simple stuff, right? Like, part 0, whoops, that's not the full name. And so we have some values there within the files. All right. What else do we want to show? I'm sorry?
Do you have any use case wherein you're going to run through in a position?
Run through what?
Use cases where the Spark being used and how it was created.
Oh, I'm sorry. Yeah, you want to know.
Because the word count definitely
There was a slide, right? Perhaps that you showed the slide where
Yeah, I don't know if I have any use cases that I can talk about that I have personal access to. I think I can talk about the 2 Sigma. So the second largest hedge fund in the world is called 2 Sigma. One of the really cool things is they have a very large cluster. And as I mentioned, most clusters are less than 20% utilized. Their cluster, these are their numbers, not mine. I haven't been able to verify, but they claim on their analytical cluster, which is a much different cluster to be talking about, they're 96% utilized, and they're using the heck out of Spark and Spark jobs. For them, their work is around their hedge fund company, so it's around financials. And there's actually more to that use case. I don't know if I have time to dive into it, but it's fascinating. The core of it is agents will gain more or less resources within the cluster based on their algorithms producing successful financial results. So a true merit-based system of cluster utilization. I think we've got like 7 minutes. Let me talk through a couple of other remaining things. Jump over here. There's a DAG that's created that's easy to follow. We can count the number of RDDs. I'll make these slides available where you can dive into them. This is a standard filter that we're going through. We can count the words. And again, if you ever wanted to see the results of something, this is just Scala stuff. So I could just say println, the count, and see results if I had an actual value in there. I feel like I'm losing everybody, so. Also super important is that I can bring RDDs in from one data source, RDDs in from another data source. They now kind of have, they're kind of homogenized. I don't know if that makes sense, but I have the ability then to start to join or union these data sets that came from completely disparate systems, which gives me the ability to do some really amazing things, whether it's analytic MapReduce type stuff, or whether I can use Spark SQL and do queries against the RDD. When we talked about Spark SQL being a great advantage of doing joins for a Cassandra, what I didn't mean to convey was that it does queries against Cassandra itself. It reads in RDDs of data from Cassandra and then does the queries, so it doesn't matter where those came from, right? It's a very beautiful thing. So with that said, oh, you know what? There is one more thing I wanted to show off, and actually we just ended up on that slide. It is common and largely valuable to potentially add or augment the functionality of Spark. Meaning I want to provide some function, some value that I want to leverage over and over again. So here you can see that I've defined a function that returns a Boolean as to whether the word is a palindrome or not, meaning it has the same letters forward or backwards if I swap them. So within the code block here, if I did a cat on, oh, hold on a second. I don't remember what I named it. Probably better ways of looking at that. This is a word count completely in Scala. I think on my slide I actually have an example of there it is, the implementation for a palindrome. Oh, this is word count again. Regardless, I do have the code example for creating it's just a simple function, just checks to see if a word is equal to the same word that's been reversed. Super simple. Does this equal true? And once you've installed it, if you will, inside of Spark, you have the ability to leverage that within your transformation functions or what have you, through your analytical functions of some sort. All right, and with that, probably out of time. We got 4 minutes left. I can stay and answer some specific questions. Some things that I left off that are probably worth talking about. Up here you can see a broadcast. If I have some kind of thing or event on one node, I can broadcast that to the other nodes that are available and make that known. Or I could, in many cases, I can broadcast some kind of value. So here's the value of something I just discovered. What else? We talked about adding functions. Yeah, I'll open it up for questions on Spark. No questions. Sorry about the one demo. I'm actually seeing if I can bring it up now. This is Spark running on a DCOS environment. Once I have it running in that environment, the one thing that you didn't see is I could actually launch that. Let me see if I have that. This is how you would launch an entire job in the real world. Spark submit. Here's the class. There's the jar. If I wanted to do it in a Mesos world, it's this bottom one right here, which might be hard to see, so I'm going to bring it towards the top. So I can see DCOS Spark run. I'm going to submit. The core number of drivers is 1. The memory is a gig. I want to do a Spark Pi test, and here's where to get the jar. In this case, this is coming from S3, but very commonly, especially in a private data center, you're going to get it from HDFS. All right. All right, thanks. Appreciate it.
Thank you, Ken.